Hi guys, this is Group 5's presentation on student productivity and well-being.
In the behavior versus productivity and well-being domain, there have been several projects that focus on particular movement and social behaviors. One study done by Evolve found that social media makes workers more productive. A con is that participants are measured by the number of accounts they had rather than how much they used them during work. Another study done by NDSU found that both anxiety and depression test results decreased after an exercise program. This study benefited by using a population exposed to anxiety but also subject to response bias. We organized our study by looking at the cons of other studies in this domain. For example, we improved the Evolve study by focusing on direct usage. For the NDSU study, we take data more naturally, making our study more generalized.
We viewed this study as extending the midterm over a longer period of time. Ultimately, we wanted to compare students' overall well-being and productivity to our behavior by day. The data sources contributing to our analysis were WHERE and PIEL, which we gathered from students in the class.
We reprioritized the project to identify and compare student habits and well-being before and after the stay-at-home order. This new focus required restructuring our design methodology to account for the most useful and plentiful data.
Looking at AWARE, we thought that the activity, screen, and call data would provide the most comprehensive look at how people's lives have changed from before spring break to now. With PIEL, we wanted to look at how productivity was related to different features of the AWARE data, and we thought we could use mood and stress to determine an overall wellness score for each day.
We used the screen count, activity type, and call type features from AWARE and binned each attribute by relative frequency to find a count for each day. To keep track of the AWARE features corresponding to which PIEL features, we assign each student a number from 1 to 13. Then to integrate this data, we merged the AWARE and PIEL data into one stacked data frame arranged by ID.
We also needed to make sure that our code would be adaptable from our group to more participants once we got the class data. For some data, this involved reapplying the same methods, but for others, it was more difficult due to different devices having different recording methods. Finally, we plan to visualize our clean data using RShiny and integrated scatter plots.
Cleaning and aggregating the activity recordings manifested in two main forms, synchronization and binning. After standardizing the different activity values, we totaled the counts of each different type, followed by binning them into two categories, still or moving.
To clean the screen data, we first had to find the total counts per day per student by binning by date and ID. To find unlocked counts, we identified the instances of blocked versus unlocked and summed the unlocked. After removing dates with missing data, we were able to see the unlocked counts relative to the total.
In order to clean the call data for each student, we removed all call instances with duration equal to 0 or disconnected call type, indicating this recording was not a valid one. We then filtered each student's call duration by date and totaled the number of calls. Binning this total number allows us to see the number of calls correlated to the well-being on that day.
After standardizing the Excel and CSV tables among the whole class, we then cleaned the data frames from each survey to only include date, mood, stress, and productivity. From here, we were able to calculate a wellness score for each day that was derived by averaging mood with 1 minus the stress score for that day. We did this so that a lower stress level would correlate with a higher wellness score.
The dataset histograms didn't include PIEL data, so 3 additional data frames combining pre and post data as compared to productivity and well-being were created. After incomplete records without both AWARE and PIEL data were removed, the frames were plotted in RShiny.
Comparing call duration and productivity, longer phone calls indicated a decrease in productivity, whereas after quarantine, call duration actually had little impact on productivity, likely because calls had become people's means of working. For call and well-being, longer phone calls relate to lower well-being in general. Interestingly, call durations are longer during quarantine, and well-being is just generally higher.
For activities and productivity, no strong relationship exists, while the post-quarantine productivity average is higher. This could result from having a lower availability of social distractions after quarantine. Relating activities and well-being, there was little correlation before quarantine, but after quarantine, higher stillness increases well-being, likely since all recreation and positive interactions now are stationary.
With screen and productivity, prior to quarantine, productivity increased slightly with active phone use, whereas after quarantine, the opposite is true, likely because phones are more often distractions rather than productive. For screen usage and well-being, higher phone unlocks tend to increase well-being in general. This may be due to the fact that phones serve as positive social distraction and stress relief. Additionally, overall phone unlocks decrease, presumably because people spend more time using their phone, limiting frequent interruptions of use.
Thank you. That concludes our presentation, and we are now open for questions.